All right, let's move on to our type 2 questions. So our type 2 questions are titled Determining What a Reaction Will Do, Trial KEQ. So for these questions, again, this will make more sense when you're looking back, but what the question is going to ask for you for is very specific. It's going to ask, will the reaction shift left, right, or not shift at all? So it's very specific wording. The key thing is that the question is going to give you the concentration of all species, but it's not going to be at equilibrium. So versus the type 1 where they gave you the concentration of species at equilibrium, this question will give you the concentration of all species, but you will not be at equilibrium. And they will also give you the value of KEQ. So let's go through a little bit of pre-knowledge here. The first thing we have to do is understand this value Q, which is your trial KEQ, or your trial equilibrium constant. The value of Q is calculated the same as KEQ, but instead of looking at equilibrium conditions, we're going to be looking at current concentrations, right? So whatever we're at this moment in time. So my biggest tip to you is to think of Q, or your trial KEQ, as a snapshot of the reaction right now. So if you had a reaction of carbon monoxide plus water vapor goes to carbon dioxide and hydrogen, the KEQ expression would be the concentration of carbon dioxide at equilibrium times the concentration of hydrogen at equilibrium divided by the concentration of carbon monoxide at equilibrium times the concentration of water vapor at equilibrium. So for KEQ, all of the concentrations are at equilibrium. Whereas with Q, which is your trial KEQ, the value of Q is going to equal the concentration of carbon dioxide times hydrogen divided by carbon monoxide and water vapor at any point in time. So not specifically at equilibrium. So then what we're going to be doing is once we calculate this trial KEQ, or this Q value, we're going to be having to look at which way is the equilibrium going to shift, and I shouldn't say equilibrium, which way should the reaction shift to reach equilibrium? So the reaction is going to shift based on this Q value because every chemical system wants to reach equilibrium. That's its goal, where the ratio of the products to reactants is this KEQ value. Whereas Q tells you the current ratio of products to reactants. So therefore, you know that the reaction is going to shift left, right, or not at all, so that KQ can match KEQ. So there's 3 scenarios that are going to happen. Scenario number 1, if your Q value comes out as less than the given KEQ, so given less than the given equilibrium constant, that's the end of the sentence, right? So if Q comes out less than the equilibrium constant, then there's too few what relative to what. So if the Q value is small, that means the ratio of products to reactants needs to get bigger. It means that there are too few products relative to reactants. The value is too small. So your reaction is going to shift right to make more products, to increase the value of Q until you reach KEQ. If the value of Q is too big, it's always products. If the value of Q is too big, you need to make it smaller. How would you do that? Well, it means that there's too few reactants relative to products. Right? It means this is too big. The products is too big. The reactants is too small. So the reaction is going to shift left to make more, I will fix that, reactants. Right? So if your Q value is too small, you shift right to make it bigger. If your Q value is too big, you shift left to make it smaller. Right? Now, third scenario, if the Q value is equal to the equilibrium constant, then the system's already at equilibrium, so no shift needs to occur. In short, the reaction shifts in the direction that moves Q, your trial KEQ, towards your actual KEQ, because that's the ratio the system wants to have at equilibrium. So let's look at some examples. First one, the value of KEQ is 10 at a fixed temperature of 600 degrees Celsius. Again, you don't have to worry about temperature in these reactions or these questions. You just want to know that it's constant. And then the reaction mixture is analyzed and found to contain 0.8 molar carbon monoxide, 0.05 molar water, 0.5 molar carbon dioxide, and 0.4 molar hydrogen. They've given you the concentration of all the species at a snapshot in time. The question is, determine which direction, left, right, or not at all, the reaction will have to shift to reach equilibrium. So the first thing we're going to do is we're going to find Q. Q is the concentration of the products, so carbon dioxide and hydrogen, divided by the concentration of the reactants, so carbon monoxide and water. And then we just put in those concentrations at that given time. So the concentration of carbon dioxide is 0.5, concentration of hydrogen is 0.4, carbon monoxide is 0.8, and water vapor is 0.05. Then we plug those into our calculator. So 0.5 times 0.4, I type in divided by 0.8 and divided by 0.05, but you can divide by bracket 0.8 times 0.05, totally up to you. And we get a Q value of 5. Then what we want to do is compare this Q value to KEQ. My Q value compared to my KEQ. Well, my Q value is 5. My KEQ is 10. Well, and I guess I could keep sig figs here, right? So my Q value is 5.0. My KEQ is 10.0. That means that my Q value is less than KEQ. Equilibrium, to reach equilibrium, we need to make our Q value bigger. We need to approach 10. So I need to increase my concentration of products, which means I'm going to shift right. So I'm going to shift right, which will increase the concentration of products, and it will increase your Q value until you reach that value of KEQ. All right, I did one. Now you do one. So pause the video and give this one a go. So your first job is to find Q. So for this one, it's the concentration of PCl3 times the concentration of chlorine divided by the concentration of PCl5. Add a snapshot in time. So when I want to put in concentration, these are all in moles. So to find concentration, you would take, for example, the concentration of PCl3, and it would be the moles divided by the volume. But because I'm in a 1 liter container, it's not going to change. So the concentration of PCl3 is the same as the number of moles because it's moles per liter and it's already per liter. So I'm just going to put all of those in. So my concentration of PCl3 is 0.60. My concentration of chlorine is going to be 0.45. And my concentration of PCl5 is going to be 0.26. So to 2 sig figs, I get a value for Q of 1.0. So again, now we want to compare my Q to my actual KEQ. My Q value is 1.0. I know when I'm at equilibrium, my equilibrium constant will be 0.5. So my Q value is greater than my KEQ. To make Q smaller, I need to increase the amount of reactants. So it's going to shift left. Now a follow-up question here, instead of asking you which way it could shift, or maybe a follow-up question could be, well, as equilibrium is approached, what will happen to the concentration of each of these species? Well, since I am going to shift left to increase the concentration of reactants, then the concentration of PCl5 will increase, and then the concentration of my products will both decrease. Awesome. Go and try those questions.